Okay, in this problem, we are given the equations for four polar equations, and we're asked to match these with four different polar graphs. All right, now for a problem like this on the exam, all I would expect you to do is basically plot this on your calculator and match. So there's not a whole lot of deep thinking involved about how to do this problem. However, for the sake of the review, let me talk about how I can observe essential properties of the functions of the graphs based on the way the function is written. All right, so number one, r is equal to 4 minus 3 cosine theta. Cosine of theta takes values between -1 and 1. So this first one, the values of r must lie between 1 and 7. So it could be as far as 7 away from the origin. It could be as close as 1 from the origin, but that's it. And also we notice that 0 is not an option. R must be between 1 and 7. So if I look at the pictures, this graph here, D, satisfies the properties in question. So here I am 7 away from the origin. At this point, I am 7 away from the origin. At this point, I am 1 away from the origin. And there's nowhere does the r equal 0. So the graph does not go through the origin. And so based on the options available, D would be the only ones that meets those criteria. Okay, number two. R is equal to 2 plus 2 sine theta. So for this one, we have that sine theta, again, takes values between -1 and 1. And so the values of r could be as small as 0 or could be as big as 4. So 0 is an option. It could go through the origin, and it can be as far away as 4 from the origin. And I see that here. Here, r is equal to 0. And at this point, r is now 4. So this point here is 4 away from the origin. And so this time the answer is A. Okay, for 3, I see that r is 3 cosine 2 theta, so the values of r are between -3 and 3. And so I could be 3 away from the origin positive or 3 away from the origin negative. Those are my extremes. And I see that here, that these points here that I'm marking are all 3 away from the origin. Now it could be 3 positive or 3 negative, meaning that theta could be in this direction and I go 3 positive, or theta could be in this direction, but I go backwards 3 negative. But either way, the extremes are 3 away from the origin, and so that would be B as my option here. So by process of elimination, the number 4 is going to be C. And let's talk about why that makes sense. Here, r is equal to 3 minus 7 cosine theta. So cosine theta takes values between -1 and 1. And so that means that r could be as big as 10 or as small as -4. So at one extreme, I will be 10 away from the origin. At the other extreme, I will be 4 away from the origin. Because when I plot r equals -4, I'm still 4 steps away from the origin, just backwards. And I see that happens here. Here, I am 10 away from the origin at this point. And here, I am 4 steps away from the origin, going backwards in this case, at this point. And here, r equals 0 is an option and actually crosses through the origin twice. Okay, so by process of elimination, I see that C is the graph. Now, again, for the sake of this exam, simply graphing on your calculator and matching is perfectly acceptable. For the sake of the review, I wanted to go over how I could read off these properties of these polar curves based on how the function is written.